Hello, in this video we will be reviewing the 2015 FRQ. For this one, we will work on problem number 4. So, for part A, it says, on the axes provided, sketch a slope field for the differential equation at the 6 points given. So, this is a very easy problem because all you have to do is just find the slope at each of the 6 points where it has the dots. And to do this, because it already gave you the differential equation, all you have to do is plug in the x and y value at each point into that equation, and that's your slope. So, for example, if we're doing 0, 2, you just plug in 2 times 0 minus 2, which equals negative 2. So your slope would just be negative 2. So then you can do the same thing for the rest of the 6. So if you do it at 1, 2, it would be 0. At 0, 1, it would be negative 1. 1, 1 is positive 1. 0, negative 1 has a slope of 1. And finally, 1, negative 1 has a slope of 3. So to recap, all you do is just find the slope at each of the points, which you just plug in the x and y value into the equation 2x minus y. So that's a very simple problem. This problem on the FRQ is worth 2 points. 1 point being the slopes at x equals 0, and 1 point where x equals 1. Now we will move on to part B. Says, find the second derivative in terms of x and y. Determine the concavity of all solution curves for the given differential equation in quadrant 2. Give a reason for your answer. So the first part is really simple. We already have the first differential equation, which is 2x minus y. And then all we have to do is take the second derivative, so we just do it again. So then the second derivative is the derivative of 2x, which is 2, minus the derivative of y, which is dy dx. Then we can substitute in dy dx because we already know it here. So that would be 2 minus 2x minus y. And that's 2 minus 2x plus y after simplifying. So then the second part asks for the concavity in the second quadrant. So we know that the concavity, when the second derivative is positive, it will be concave up. And then when the second derivative is negative, it's concave down. So when it asks for the second quadrant, there's a trick, or it's very simple, because if we just look at this pattern, we can see that the x is always negative and the y is always positive. So if we plug that information into the second derivative, we can see that the resulting number is always positive, because a negative x times this negative makes it always positive, and the y is always positive. So positive plus a positive is always positive. So then that means that this is concave up because the second derivative is positive. In the second quadrant. Okay, so this problem is also worth 2 points. The first one being finding the second derivative, and the second point from finding that it is concave up and justifying your answer. Now we will move on to part C. Says, let y equals f of x be the particular solution to the differential equation with the initial condition f of 2 equals 3. Does f have a relative minimum, a relative maximum, or neither at x equals 2? Justify your answer. So remember that we need the critical numbers in order to be either a relative minimum or a relative maximum. And the critical number is when the slope is either 0 or undefined. So first thing we have to do is plug in 2, 3 to the differential equation to see if the slope is 0 or undefined to check if it's a critical number. So our differential equation was 2x minus y. And then our point is 2, 3. So that would be 4 minus 3, which equals 1. And 1 is not defined or 0, which means that this is neither a relative minimum or a relative maximum, because 1 does not equal 0, and therefore it means that it's not a critical number. So this point, its slope is not a critical number, which means that it is neither a relative minimum or a relative max. So that's it for this problem. It's very simple if you understand the critical numbers. And then you just check to see if the slope is what the slope is. So this problem is also worth 2 points. One is considering that the derivative, you have to plug in the 2 points 2, 3. And then the second, so that would be this part. And then the second point would come from your justification and saying that it is neither. Okay, so now we move on to the final part. Says, find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. So this problem is very tricky because it requires a lot of substitution. To begin with, we know that dy dx is equal to 2x minus y. And we know that we're trying to find y equals mx. We're given y equals mx plus b, and we're trying to find m and b. So the first step is to take the derivative of this to set them equal to each other. So then we would have dy dx is equal to m. This is because the derivative of b is just 0, because b is a constant. So then we can set dy dx equal to this, because they are equal. Then we're trying to get rid of one variable, so we get rid of y. Y is equal to mx plus b, so we can plug that back in. Then we can simplify, so we would have 2x minus mx minus b equals m. And we want to set this equal to 0 because that's the easiest way to find the solution. So we would have 2x minus mx minus b minus m equals 0. This way, if we have, after we factor, to make it look neater, so we would have x times 2 minus m minus b plus m. It would be much easier to solve for 0 because we would just have 0 minus 0 equals 0. So we're just trying to find 0 for both of these. And we know that 2 minus m, if we make that 0 times x, that would be 0 no matter what. So we don't need to find x. We can just focus on these two. So first, because this only has one variable, we'll solve this side first. So we have 2 minus m is equal to 0, so m is equal to 2. Then, because we know what m is, we can plug it into this, and this would also be set equal to 0. So b plus 2 is equal to 0, so b is equal to negative 2. So our final answer is m is equal to negative 2, b is equal to negative 2, which is the solution to the differential equation up here. So this problem is worth 3 points. The first point is from knowing to take the derivative of this. The second point is setting the derivative equal to this. And those parts are very tricky because sometimes you wouldn't think of substituting like that. And the last point is, of course, the answer itself. So if you wanted to do more problems like these, you could just search up AP Calculus 2015 FRQs on Google, and it would show you all the questions and answers. Or you could go to collegeboard.org and then search up those. Thank you for watching. I hope this video helped. Again, we reviewed question 4 for the 2015 FRQ. Thank you.